Hello, this is Charlene. This video is about quadratic and radical functions. We are going to be solving quadratics and radical functions. This first quadratic we are going to solve by factoring. But let's just talk for just a moment, what makes this a quadratic? Well, if we look at the power on my x, the highest power on my x happens to be a 2. Now, in reality, there's an invisible 1 on this x, but I'm only concerned with the largest power on the variable. The largest power is a 2. That's an x squared, and x squared means that it is a quadratic. So that does confirm that we are dealing with a quadratic function here. So before we start to factor it, we want to make sure that our quadratic is in standard form. So this is standard form. Ax squared plus bx plus c equals 0. So if you notice, everything is on one side, all three terms, and 0 is on the other side of the equal sign. So we are going to move the 6 over to the other side. So when we do that, we're going to rewrite it as x squared minus x minus 6. Because what did I do? I subtracted 6 from both sides. It went away over here. Now, technically, I could write equals 0. However, I don't really need that while I'm factoring it. It's kind of in my way, so I'm just going to leave it off. And let me make that x a little bit better here. Okay, so got an x right there. Okay, so the first part of the process of factoring this quadratic is that I am going to take the invisible 1 right here. I'm going to multiply it times a 6. That gives me a 6. I'm going to find factor pairs. 1 times 6, 2 times 3. 3 is the next number, but I've already got a 3. That means I'm finished. So now I'm going to consider the fact that I have a 1 as the coefficient in front of my middle x term. So I want to ask myself about my factor pairs. Can I add or subtract a 1 and a 6 and get a 1? No, I cannot. Can I add or subtract the 2 times 3, the 2 and the 3? Can I add or subtract those and get a 1? Yes. So that's going to be my chosen factor pair. So I'm going to go ahead and put 2 sets of parentheses here. And I'm going to take the square root of x squared, and I'm going to put the answer in the front. So the square root of x squared is x. It goes in the front, Then I'm going to take my chosen factor pair of 2 and 3 and put them in the back of my parentheses. Now I'm going to consider that this is a negative 1. So how can I get a negative 1? What sign can I put here in front of the 2 and here in front of the 3 in order to get a negative 1 when I add them or subtract them? Well, if this is a negative number, typically my bigger number, the 3, will have a negative. So I'm going to put a negative in front of that and a plus 2. And that makes sense, right? Because plus 2 minus 3 does indeed give me a negative 1. So that's going to work out. So those are my factors. Those are my factors. Let me move this a little bit out of my way so I can have more room here. So those are my factors. Those are not my solutions. They are just the factors. We've done the first step in finding solutions. So the next step that I want to take is to set my factors equal to 0, which is called the zero product rule. Zero product rule. Okay? And that just means that I am going to take my factor pairs, each one of them, or my factors, I shouldn't say factor pairs. It is a pair of factors. They're two expressions. So I'm going to take my first factor, x plus 2, and set it equal to 0. And then I'm going to take my second factor, x minus 3, and set it equal to 0. And now I'm going to solve. So each one of them. So minus 2, these will cancel. So x is equal to negative 2. And then I'm going to do plus 3 and plus 3. Those will cancel. So x is going to be equal to 3. So these are my solutions. These are my solutions. But I can also call them x-intercepts. This is where the parabola that's going to result from this quadratic, it's going to cross the x-axis, so that means they are called x-intercepts. X-intercepts. We can also call these solutions zeros if we want to. Zeros, because this is where the y value, which is the function value, will be at 0. The y value will be 0. You'll have a point of -2, 0 as one of your solutions in the x-intercepts, and this one will be a +3 with the y value, the function value, equal to 0. So solutions, zeros, x-intercepts. Oh, we can also call them roots if we want to. So all those words are kind of interchangeable for the answers of solutions, but these are my two solutions that I have found through the process of factoring the quadratic. Our next problem says that we are going to solve by using square roots. So the first clue that we have in our quadratic that tells us we're going to use the square root method is the fact that there is no x term. If you notice, there's a 5x squared term, and of course that x squared term does indicate that this is a quadratic. And then we also have a constant. It's like 5x squared minus 4 is equal to 11. Well, 4 and 11 are just numbers or constants. So this is typically the setup. You're going to have x squared minus a number is equal to a 0, but you have no just plain old x term. That tells us we're going to use the square root method. So our first part of the process is to isolate that x squared term. I want to isolate the squared term. So I want to get the x squared term on one side of the equal sign, and everything else is going to be on the other side of the equal sign. So in this problem that they've given us, we need to move this -4 over to the other side. So we're going to go ahead and add 4 to both sides. And these 4's will cancel out. I end up with 5x squared is equal to 15. Okay, we continue just using our Algebra 1 order of operations processes to divide out the 5 on both sides. These will cancel, and I end up with x squared is equal to 3. Okay, at that point, we've now isolated our x squared on one side of the equal sign, so that means we are ready to use the square root method. That means I'm going to take the square root of both sides. However, we need to also remember that on the radical answer side, I need to add plus or minus, because x squared quadratics will typically have two answers. They will typically have two answers. So that means that if we put a plus or minus, that gives us two answers. So I'm going to put plus or minus on the answer side. Okay, so now I'm going to take the square root of a square, which means the square root and the square will cancel each other out. I end up with x is equal to plus or minus square root of 3. Okay, that is the answer to this quadratic. It will have two x-intercepts. It'll have one x-intercept at negative square root of 3, and it'll have a positive x-intercept at positive square root of 3. But that is the solution to our original quadratic. Our next problem says that we have x plus 4 quantity squared is equal to 40. Our normal setup is x squared is equal to some number, and this alerts us that we can use the square root method. This is an expression that is squared, but we can solve it exactly the same way. So an expression squared equal to some number, we can still use the square root method. It's the same process. So we are going to, well, we've already isolated, like this is only the expression squared. It's already isolated, right? It's already isolated. So we don't have to do any extra work. So let's go ahead and start the process. We're going to take the square root of our expression that is squared, and we are going to take the square root of the 40. And if you remember from the previous problem, on the radical side, radical answer side, we always need to put a plus or minus to ensure that we end up with our two solutions that we should have for a quadratic. Okay, so we are going to cancel out this square root and this square, and that leaves us with the expression, and then that is equal to plus or minus 40. So now we need to deal with this square root of 40. So let's talk about that. So square root of 40, I can break that down into some factors. I can say 4 times 2 times 10, right? Is that right? No, that is not right. Okay, 2 times 5. I should probably just go ahead and do the extra step. 4 times 10, right? There we go. And then that is equal to 4 times 2 times 5. Okay, so I can take the square root of the 4, right? And a 2 can come out to represent the square root of 4. But the 2 and the 5, I cannot take the square root of a 2. I cannot take the square root of a 5. Those are prime numbers. So I am going to let the 2 and the 5 stay in the house, and we will have to put them back together, which means that this is going to be equal to 2 on the outside of the radical, and 2 times 5 stays in the house. So that means that I can rewrite this over here as x plus 4 is equal to plus or minus 2 radical 10. Okay, now using our order of operations, we are going to subtract 4 from both sides, minus 4. Those will cancel out. So x is equal to negative 4 plus or minus 2 radical 10. So that gives me two solutions to my original quadratic. So this is the answer to the original quadratic that we started out with. Now our next problem is going to use a different method to solve. We are going to use the completing the square method. There are times when we have to use completing the square, or, well, there is another method that we can also use, but typically you will complete the square when this quadratic cannot easily be factored. So let's try that for just a second. Can we factor this easily? So there's an invisible 1, and we're going to multiply it times the 2. We're going to get a 2. What are the factor pairs of 2? 1 and 2. There are no other factor pairs. And 1 and 2, can I add or subtract 1 and 2 and get an 8? Never. So therefore, this quadratic cannot be factored. So therefore, we need to find another method to solve it. So this is one method that we can use, is completing the square. Completing the square uses what I refer to as the magic bullet for completing the square. And it is b over 2 squared. Well, where do we come up with our b? Our b comes from the standard form of a quadratic. Normally we have ax squared plus bx plus c. So the b number is whatever number is the coefficient to the x term. So in our quadratic over here, we have x squared minus 8x plus 2. The b is going to be the 8. Technically, it's a negative 8, but it really doesn't make any difference because we are going to square it, and a negative squared will always turn back into a positive. Okay, so, but here's how we're going to set it up. We've now determined that this constant at the end of our quadratic prevented us from being able to factor it. So that means that 2 is not working for us. So we are going to rewrite this as x squared minus 8x plus blank, and then we are going to subtract the 2 from both sides. So we're going to do minus 2 and minus 2. So it's going to be equal to minus 2, because that 2 is going to disappear. But if I add a blank to one side of my equal sign, I need to add a blank to the other side. But what am I going to fill with that blank? I'm going to put my magic bullet in that blank. So it's going to be b squared, b over 2 squared. It's going to go in both blanks. Well, let's go ahead and fill it in. What is the b? We determined that 8 or negative 8 is the b. So that would be 8 divided by 2 squared. Okay, so the magic bullet goes in that blank. So we're going to create a new trinomial on the left side of our equal sign. So let's go ahead and write down the next one. X squared minus 8x plus some number. Well, that number is whatever this is equal to. Well, what is this equal to? 8 divided by 2 is 4, and then 4 squared is 16. Okay, so it means I'm going to have x squared minus 8x plus 16. And then that is going to be equal to negative 2 plus 16, which is 16 minus 2, which means it is 14. Okay, so we call this the completing the square method because I have now just completed the square. This whole little part right here is a perfect square trinomial. That is the whole goal of completing the square, is to create a perfect square trinomial. When we have a perfect square trinomial, we can factor it easily according to a pattern. So my pattern for this is going to be, find my marker here, I'm going to put 2 sets of parentheses. And I am going to take the square root of x squared first. That's going to go in the front. So the square root of x squared goes in the front and goes in the front. And then I have the square root of 16 goes in the back. Square root of 16 is 4 and 4. And then this sign that's in the middle is going to be the sign of both of my parentheses. And so that is equal to 14. Okay, but now we can do a shortcut, right? This right here, this x minus 4 times x minus 4, we can shortcut that, right? Because we can rewrite that as x minus 4 squared, right? Okay, and that's equal to 14. So here we go. We have just used the completing the square method because this piece of it has now become a perfect square trinomial. It allowed us to factor it according to the pattern. So like this perfect square trinomial right here has been factored into 2 factors, x minus 4 times x minus 4. Then we can write it as a shortcut. But now what do we have? We now have a setup that's an expression that is squared equal to a constant. We can now use the square root method. So I can take the square root of both sides. Square root of both sides. Remember, we have to put plus or minus on the square root answer side. And now let's see. Let's move this up here just a little bit. I'm going to end up with x minus 4 because what happened? My square root canceled out my square. It left me with just the expression x minus 4. And that is going to be equal to plus or minus the square root of 14. Okay, so the factors of 14 are 2 and 7. 2 times 7 is 14, but I cannot take the square root of a 2. I cannot take the square root of a 7. So that means that 14, the whole number, has to stay under the radical. But I'm now going to add 4 to both sides. Add 4 plus 4. These 4's will cancel each other out. And I end up with x is equal to plus 4. So I'm going to put a plus 4 plus or minus square root of 14. So this is are our 2 solutions, right? We're going to have a plus version and a negative version. These are the 2 solutions for my original quadratic that we started out with. And we used the completing the square method, and then we also used the square root method at the end of it to find the final solutions. Our next problem is going to use a different method to solve for the solutions. It is going to be using the quadratic formula. This is the quadratic formula. There is only one quadratic formula, and I wanted to make sure that you can distinguish between a quadratic formula versus a quadratic equation. Okay, so all three of these are quadratic equations because they all have x squared. These are all unique parabolas. They would graph differently. Those are all equations, but there is only one quadratic formula, and this is it. Okay, and then we also have the general form of a quadratic equation. Um, and any of these can be put back into the general form. And we use that general form because it helps us to identify the coefficients. The coefficients of a quadratic and the constant there are used in the quadratic formula. You got to know which number is the B number, which is the A number, the C number, the A number. So we use the general form to help us know what numbers to plug into or substitute into the quadratic formula. So let's get rid of all of this. We're only going to work this first one. These other two that I listed here or previous problems that we worked on this video. So I just wanted you to know that the quadratic formula, we can use the quadratic formula to solve that. We can use the quadratic formula to solve this. Quadratic formula is a universal formula which allows us to solve any quadratic, and we can use it on any quadratic. So, but we're going to use it on this first one. So we've got to identify our A, B, and C. So our coefficient to the x squared term is A, and there's in our equation, it is a 3. And then we also have a b is the coefficient to the x term. So that was going to be the -6. We do keep the negatives if there are negatives with it. And I just noticed something. I have equals and then the last constant. Well, that is not in standard form. In order to be standard form, I have to have equal 0. So that means that we need to move this -1 back to the other side so that all of my terms are on one side of the equal sign. So let's go ahead and do that. Let's go ahead and we're going to add 1 to both sides. And I'm going to end up with 3x squared minus 6x plus 1. And technically it would be equal to 0, but like I said, I don't need the equal to 0 in order to solve this, so I'm just going to ignore that for a moment, not write equal to 0. Okay, but again, going back to my A coefficient is still the 3. My B coefficient is still the -6. And my C coefficient or constant is a +1. So that means I now know where to plug things in. I've got an A is going to go here and here, and the B is going to go here, here, and that's all. And then my C is going to go in this position. So we're just going to plug all those numbers in and work it out and simplify it. So, and this is so that we can find x, the values for x or x-intercepts for our quadratics, which is going to graph like a parabola, which does have the x-intercepts. Okay, so we're going to have -b. So -b means -6. And that's plus or minus. And then we've got the square root of b squared. So it's a -6 squared. And that's going to be -4 times the A. Well, the A is the 3. And that's times the C, which is the 1. And then all that is divided by 2 times A. So it's going to be 2 times 3. Now we just keep simplifying it and working it down. So that is going to turn into, that's going to be equal to a +6 plus or minus 36. Because -6 squared is 36. And then it's a negative times a positive times a positive, which means it's still going to be negative. And 4 times 3 times 1 is 12. And then all that is going to be divided by 2 times 3, which is 6. So now we're going to reduce it some more. So 6 plus or minus square root of 24 divided by 6. Okay, so we need to consider the square root of 24. So let's go up here and let's reduce the square root of 24. So I can do the square root of 24 is also equal to 4 times 6. I can take the square root of a 4. It's going to be 2. 2 is going to come out to represent the 4. But 6, we cannot take the square root of a 6. So 6 is going to stay in the radical house. And so that's going to end up being 2 radical 6. So square root of 24 is equal to 2 radical 6. So now I can rewrite that. Okay, that is going to be 6 plus or minus 2 radical 6, all divided by 6. There's a common factor. The common factor between 6, 2, and 6 is 2. So that means I can divide out the 2. So 6 divided by 2 is 3, plus or minus 2 divided by 2 is 1, radical 6. And in the denominator, 6 divided by 2 is also 3. So this provides us with both of our solutions, or x-intercepts, for our original quadratic that we started out with. The next part of our video is going to be about radical equations. It's listed a restriction here. It says that the stuff under the radical must be greater than or equal to 0, which is another way of saying no negatives. We don't want any negatives under the radical. No negatives. Anytime you get a negative under the radical, you're going to get into complex numbers. So in solving for them, we are not going to deal with negatives, any answers that gives us a negative under the radical. Okay, but our rules are basically number 1, isolate the radical, and then number 2, we're going to undo the radical. So here in our problem that they've given us, we've got a radical x. So I basically want to get that radical x all by itself. So using our order of operation rules, I'm going to subtract 3 from both sides of the equal sign. So that's a 3. It doesn't look like a 3, does it? Okay, so 3 minus 3 cancels itself out, and then I end up with 2 radical x is equal to 9 minus 3, which is 6. And then continuing to use order of operation rules, I can divide out the 2. So I'm going to divide 2 out of both sides of the equal sign. Those will cancel, and I end up with radical x is equal to 6 divided by 2, which is 3. And so now we have isolated our radical. We now have just radical x. There's nothing else except for the radical. It's all by itself. So now we can undo the radical. So how do I undo a square or a square root? Well, I square a square root to undo it. And so if I do it to one side of the equal sign, I also have to do it to the other side of the equal sign. So that means that this radical and this square are going to cancel each other out. I am going to end up with x is equal to 3 squared, and 3 squared is equal to 9, and I am finished. X equals 9 is the one x-intercept of my radical equation that I started with. Our next problem says 4 times the radical of, or square root of x plus 4 minus 3 is equal to 17. So again, we are going to isolate the radical first. So let's go ahead and do that. Order of operations says I need to add 3 to both sides. So add 3, those will go away. Then I end up with 4. Square root of x plus 4. And that is going to be equal to 20. And then continuing with order of operations, I can divide out the 4 on both sides. These 4's will disappear. And now I end up with radical or square root of x plus 4, and that is equal to 5. Okay, so I have now isolated my radical. I only have square root of x plus 4 on this left side of the equal sign. So now I need to undo my radical. So I'm going to undo my radical or my square root by squaring it. If I square it on one side, I have to square it on the other side. So the radical cancels out the square, and I end up with x plus 4 is equal to 25. Now I can subtract 4 from both sides, and these cancel out, and I end up with x is equal to 21. And that too looks funny. 21. Okay, and going back to the no negatives under the radical, we might want to just double check. When I plug in 21 in for the x, that gives me a square root of 21 plus 4, which is square root of 25. That definitely is not a negative, so our answer is good. We are good to go with x equal to 21. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.